So myself, Mohammad Ibrahim, Assistant Professor, Department of Electrical Electronics Engineering, KPR Institute of Engineering and Technology, Coimbatore. So I hereby giving in some instructions to draw the circuit diagram and the remembrance for an electrical machines laboratory 1. Says of electrical machines lab 1 is concerned. So we have an DC machines. So the machines consist of an motors and generators. So often we have a more struggle to draw the circuit diagram, and we are remembering, and we are not getting an knowledge to draw the proper circuit diagram. So in order to get a certain knowledge towards to draw the circuit diagram, so I hereby have some knowledge towards giving and some input towards an circuit diagram. Okay, so what we are going to take is then the basic circuit diagram, which is called as a load test on DC shunt motor. So when we try to learn this circuit diagram, so by understanding the things, so we can able to give a circuit diagram for whatever may be the electrical circuits may be. Okay, so first of all, so we have to get an idea of the title of the experiment first. So from the title of experiment, we have to go from the back and towards an front. Okay, so as of load test on DC shunt motor, so we are going to consider the motor first. Okay, so the motor consists of an major two windings. One is called as a field winding and armature winding. Okay, so this is of the first thing what we have to write. Okay, so as of field is concerned and armature is concerned, it is an universal structure that we have to draw similarly what we have given in the slide. So next one what we are going is called as a DC shunt motor. That is what we have drawn is a motor which has two major winding, field and armature. So the previous word is called as a shunt motor. So it is called as a shunt is called as a parallel. So we are paralleling the field winding and armature winding. Okay, so next thing is called as an DC shunt motor. So we are need to give a DC, where DC is called as a direct current. So we are need to give a DC supply to the shunt motor. So motor is a field and armature, shunt is a parallel connection of field winding armature winding, and we are giving a DC supply to the both the field and armature winding. Okay, so next one is called as a load test on DC shunt motor. So we are need to test the performance of the machine by adding a load. Okay, so as of motor is concerned, our load is an of mechanical system. So we are adding a brake drum as a load here. So I think you can able to see the things what I am explaining, right? Okay, so next thing we have to add the meters. So as of to determine the performance of an electrical machines, so we are need to know the readings of an what is voltage and what is current in the machine, right? So in order to find the performance of a machine, so we are need of an voltage and current. So we are adding in voltmeter in parallel and ammeter in series. So next thing, so we are need to add the starters. The starters is used to start the it is not used to start an electrical machine. It is used to limit the starting current of an electrical machine. I think you are all well known about the starters, right? So there are three types of starters are there. One is called as a 2-point starter, 3-point starter and 4-point starter. As of DC shunt motor is concerned, so we are giving a 3-point starter where LFA, where L is called as an line, F is called as a field winding which is connected to the field, and A is called as an armature winding which is connected to the armature of the DC shunt motor. Okay, so next one, so adding of rheostat. So we can add a rheostat either in a field winding or in terms of an armature winding for to get a speed above rated speed. That is if consider our motor is of 1500 rpm, if we are need of a speed above 1500 rpm, so we are need to add a rheostat towards an in series with the field winding. Okay, so in case if you are need of an speed less than 1500 rpm, so we can add a rheostat in an armature winding, so we can reduce the speed of the machine. So in this circuit diagram we have added the rheostat so towards a field winding, because in order to increase the speed of an emission we have added towards here. So next one is then a protection device. So next protection device, so in order to protect the system, that is protect our motor from an abnormal condition from the main supply, so we are need to add on a fuse rating, that is an fuse towards, that is an input of an electrical supply of an DC motor. We are adding in a protective device which is called as an fuse. Either we can add on a conventional fuse or we can go for an MCBs, miniature circuit breakers. So next one is an adding switches for disconnection. So the last one is concerned switches. So the purpose of switches used to, if you have any problem towards a motor side, so we have to disconnect the supply from the motor. So we are adding in switches between the main supply and then DC motor. So that's what so for drawing in circuit diagram, so from we have to go from the backwards towards in front. Okay, so as of final circuit diagram is concerned, so this is a first one. So field and armature winding, this is the first one. So we have to connect the field and armature winding in parallel. So next one we have to given a DC supply, and next one we are adding the load. So next one we are adding the load. Next thing what we are doing is then adding the meters, that is ammeter and voltmeter. So next thing, so we are need to start the machine at a smooth manner. So the starter has been used, so this is called as an 3-point starter. So next thing is called as in order to change the speed of a machine, so we are need to add the rheostat either in field side or armature side. So based upon our requirements, so we can add the rheostat. So next one, the protection of the machine, so we are adding the fuse towards it. And next thing is to, in order to make any maintenance towards a machine, so we have to disconnect the supply, that is we have to disconnect the machine from the main supply. So we are adding an switch towards it. So the switch is called as a double pole, single throw, and S is called as a switch. So this is a simple diagram that we can able to understand with this. Thank you.